So today we were going to discuss all about circle. Circle is a set of all points in a plane that are at constant distance. The radius from the fixed point. The fixed point is called the center of the circle. So here we have problem number 7. A lighthouse is located at the origin. The beam of the lighthouse can be seen after 15 miles and you are on a ship that is 8 miles east and 10 miles north of the lighthouse. Will you be able to see the lighthouse beam? Determine the standard and general form of the circle. Solve and sketch. So to check if our ship's position is inside the circle, we were going to use the Pythagorean theorem. The ship is at 8 and 10, the lighthouse is at the origin 0, 0. So a squared plus b squared equals c squared. Our a is 8 and our b is 10. So we were going to solve for c because c is unknown. C squared equals 8 squared plus 10 squared. So c squared 8 times 8 equals 64. And then 10 times 10 equals 100. So next we were going to add the 64 plus 10 equals 164 and the square root of 164 is 12.81. So our distance is 12.81 miles. So therefore the ship will be able to see the lighthouse. So we were going to solve for the standard and general form. Step 1. Identify the circle's data. Center at the origin, C equals 0, 0. Radius beam reaches 15 miles or our radius is 15. Step 2. Write the standard form for the circle with center quantity of h and k and radius quantity x minus h squared plus quantity of y minus k squared equals radius or r squared. Substitute h equals 0 and k equals 0 and then our radius is 15. So quantity of x minus 0 squared plus quantity of y minus 0 squared equals 15 squared. So our standard form is x squared plus y squared equals 225. We get a 225 because 15 times 15 equals 225. So let's move on. So we were going to solve for the general form. Step 3. Convert the general form. The general form collects everything on the side and looks like x squared plus y squared plus dx plus ey plus f equals 0. From the standard form, x squared plus y squared equals 225. So x squared plus y squared minus 225 equals 0. Here, so our d is 0 and e is 0 and f is negative 225. So like gimove lang nato siya. So x squared plus y squared minus 225 equals 0. So our final answer is for the standard form is x squared plus y squared equals 225, and for the general form is x squared plus y squared minus 225 or negative 25 equals 0. So the ship at 8 and 10 lies inside the circle so it can see the lighthouse beam. So here is a quick sketch of the circle and the ship's location. The blue circle shows the lighthouse beam range of 15 miles. And the red dot is the lighthouse at the origin 0, 0. And the green dot of the ships at 8 and 10.
Today's video we're going to solve an interesting problem. So how to find the perfect spot for light source in a paraboloid-shaped spotlight. Sounds cool, right? This kind of setup is used to everything from satellite dishes to searchlight, so let's get into it. Alright, here's what we know. The spotlight is shaped like a paraboloid. So, do you know what a paraboloid is? A paraboloid is this. The diameter of the opening is 12 inches. Diameter of the the diameter of the one is 12 inches. So 12 inches. This is the diameter of the opening of the paraboloid. So 12 inches. Then the depth from the vertex to the opening is 8 inches. So 8 inches na siya. 8 inches. This is the depth of for the vertex. So our goal is to figure out where to place the light source so that the beam is focused and travels parallel to the paraboloid's axis. To do that, we need to use properties of a paraboloid. So we need to get the paraboloid here. So the paraboloid's equation is y equals x squared over 4f. This is the paraboloid's equation. So here's paraboloids. This equation is what we need for to solve our problem. So this equation is what we need for to solve our problem. So next is first thing first is diameter of the opening here. So the y is the height of at any point on the paraboloid. The x is this horizontal distance from the center, and the f is the focal length, which is we want to place the light source. So f. And the first things first, the diameter of the opening is 12 inches, so the radius is half of that. So we need to find. So r is equals 12 2. So 12 divided by 2. So r is equals to 12 over 2. So we need to divide them. So 12 divided by 2 is 6 inches. It's 6 inches. So r equals 12. R equals 12 over 2. So to get 6 is we need to divide this. So 12 divided by 2 is 6 inches. So now we'll use the radius later in the equation. So now the depth of the paraboloid, which is the distance from the vertex to the opening, is 8 inches. This is the value for y, and when x is equals to 6. So keep that in mind because we will plug this value into the equation in a minute. Okay. So here. So we all know that our y is 8. Y is 8. So just put it. So y is equals to 8. Then our x is equals to our 8 is equals to 6. Now, now we need to, so now we need to simplify this. So 6 times 6 is 36. So here. Now we need to solve the focal length. So we need to multiply both sides by 4f. So we need to simplify this. So 6 times 6 is 36. So answer will be 8 equals 36 over 4f. So we need to multiply both sides. So we need to multiply 8 times 4. So 8 times 4 is 32. So the answer will be 32f. 32f equals 36. So now get another formula again. So now f is equals to 36 over 32. So we need to divide this. So 36 divided by 32. So the answer would be 1.125 inches. This will be the answer, 1.25 inches. So the focal length is 100.25 inches. Now the important part, the light source should be placed at the focus of the paraboloid, which is the distance of 1.225 inches from the vertex along the axis of symmetry. So to summarize, the diameter of the paraboloid is 12 inches. So the radius is 6 inches. The depth is 8 inches, which gives us the point with substitute the values into the equation. Solving the focal length, we get 1.125 inches. That's where you want to replace your light source. Simple, right? That is all. Thank you for listening.
Hello everyone, so I'm going to solve a problem about an ellipse. A semi-elliptical tunnel is 26 feet wide at the base and 8 feet tall at the center or the highest point. How high is it 8 feet away from the center of the base? So let's set up the equation for the ellipse. Since the tunnel is semi-elliptical, we can we can model it using the equation of an ellipse centered at the origin 0 and 0. The general form of an ellipse is x squared over a squared plus y squared over b squared equals 1. So where a is the semi-major axis or half the width, and b is the semi-minor axis or the height. Next is, let's determine the values of a and b. So the width of the tunnel is 26 feet. So the semi-major axis is a equals 26 over 2 equals 13 feet. So our A is 13 feet. So let's move on to find the value of B. So the height of the tunnel is 8 feet. So the semi-minor axis B is equals to 8 feet. So our B is 8 feet. Now that we got the values of A and B, we can write the specific equation for this tunnel. So our equation is x squared over 13 squared plus y squared over 8 squared equals 1. Now we are going to simplify it. It's going to turn into x squared over 169 plus y squared over 64 equals 1. Since we need to find the height y when x is equals to 8, we want to find the height of the tunnel 8 feet away from the center. So we need to find y when x is equals to 8. So let's put 8 into our equation. It's right here. X squared over 169 plus y squared over 64 equals 1. Now we are going to simplify it. It's going to turn into 64 over 169 plus y squared over 64 equals 1. So the next step is, let's transpose 64 over 169 to the right side. So our equation will turn into y squared over 64 equals 1 minus 64 over 169. Now we are going to subtract 64 over 169. So how do you subtract it? So we are going to calculate 1 minus 169. That will make it to 1 equals 169 over 169. So 169 over 169 minus 64 over 169. That will give us the answer of 105 over 169. So y169, just copy the denominator. So y squared over 64 is equals to 105 over 169. So the next step is, we will multiply both sides by 64. So 64 bracket y squared over 64 equals 105 over 169 bracket 64. So let's cancel 64 and multiply 105 with 64, and that will give us y squared equals 6720 over 169. So the next step is, we are going to extract the square root to get y. So y squared square root equals 6720 over 169 square root. So let's cancel that and the squared. That will give us y equals 6720 over 169 square root and square root. So the next step is we will find the square root of the denominator, which is 169. So y is equals to square root 6720 over 13. So now that we got the square root of the denominator, the next one is we will find the square root of the numerator. So y is approximately equal to 81.9756 over 13. Now we are going to divide 81.9756 to 13. That will give us y is approximately equal to 6.3058 or 6.31. So the height of the tunnel 8 feet away from the center is approximately 6.31 feet. So the height of the tunnel 8 feet away from the center is approximately 6.31 feet.
Hi guys, it's me, Princess Ilinianos from STEM 11 Olive Green. So I am teaching you on how to solve or find the equation of a hyperbola. So let's start. We are given the situation. Two radio signaling stations A and B are 120 kilometers apart. The radio signal from the two stations has a speed of 300,000 kilometers per second. A ship at sea receives the signal such that the signal from station B arrives 0.0002 seconds before the signal from station A. What is the equation of the hyperbola where the ship is located? Set the midpoint of A and B as the origin. Let's list down the given. Distance between station A and B equals 120 kilometers. Radio signal speed equals 300,000 kilometers per second, which is represented by variable B, and times difference equals 0.0002 seconds, represented by variable t. So let's solve. In hyperbola, this distance represents 2c, where c is the distance from the center to each focus or our station. So 2c equals 120 kilometers. Divide both sides by 2, which give us c equals 60 kilometers. Point on the hyperbola to the two foci is constant. So constant difference is 2a. 2a equals v times t. We'll substitute 2a equals 300,000 kilometers per second times 0.002 second. Let's cancel out seconds, which give us 2a equals 60 kilometer. Let's divide both sides by 2. So a equals 30 kilometer. We know a equals 60 kilometers and c equals 30 kilometers. We need to find b. In Pythagorean theorem, c squared equals a squared plus b squared. We are finding b, so b squared equals c squared minus a squared. Let's substitute the given. B squared equals 60 squared minus 30 squared. B squared equals 3,600 minus 900. B squared equals 2,700, which give us b is equals to square root of 2,700. The equation of a hyperbola with its center at the origin and foci on the x-axis is x squared over a squared minus y squared over v squared equals 1. Now let's substitute. X squared over 30 squared minus y squared over square root of 2700 squared equals 1. We know that squared and square root is cancelled out. So our equation is x squared over 900 minus y squared over 2700 equals 1.